For this last lecture, I'm going to actually skip number 63. I'm going to still ask you to do that on your own. And if you have trouble with any of these, please feel free to ask me questions either in class or in an online discussion that we happen to be having sometime afterwards. But just for the sake of time, I'm going to bypass this particular question and go on to the last one, which has to do with bond enthalpies. And this is going to be a little different from what we did in chapter 5. We are going to be looking at information that kind of goes into what this whole compound has going on and look at each individual bond, how much energy is involved in breaking it, or how much energy is released when these bonds form. So for this first one, we're going to be looking at saying, okay, what happens when these compounds are breaking and forming new things. So we're going to focus on this one here. But something we have to figure out, well, we'll come to the numbers here a little bit later on. So just think of it as far as taking a toy apart, like Legos. You have to take all these pieces apart. So this is a compound, this is a little bit tight, but just see that these are two different compounds. You have to take all these bonds apart for this, and then put it back together. So our thought process is, and this is for A, is we're going to do one of these little sigma-y things. And the way you want to think about it, it's the difference between the bonds broken, the sum of all of them for the entire thing, minus, and the reason we do minus, that's terrible, but the reason we do minus is this is an exothermic process over here. But again, we're just looking at the difference. You want to do them in whole number or just positives. It's the difference. This is energy going in, positive. This is energy leaving, negative. But a bond is a bond is a bond, broken, formed, it doesn't matter. It's the same exact amount of energy, and it's a difference. You just have to understand, is this energy going in or energy going out? And this is the way we write it. So we look at these minus those. So let's give an example. How many carbon to hydrogen bonds do we have here? So I'm going to write this out as far as carbon to hydrogen. And I'm just going to catalog the number of bonds first, and then I'll get a number later on. There's a carbon to carbon double bond here. So I've got some carbon hydrogen bonds, I've got carbon carbon bonds. That's all I got going on there. Over here, still going to do a plus. I've got a oxygen to hydrogen bond, certain number, who knows how many. And I have a oxygen to oxygen single bond going on here. So I have a sum total of all these things that I need to add up eventually. And then over here, give myself a little more room. I have, let's see, I've got hydrogen, oxygen, is because I'm seeing that, I'm going to start with that. So I'll write it the same way so I can see it. Plus, what else do I got going on? Carbon hydrogens again. Carbon, hydrogen, certain number of those. And then looking else, I've got carbon, oxygen again. Running out of space here. Plus, I'll write it down here. And I guess I got a carbon to carbon single bond. That is different. And then I'll put the little bracket guy there to show that. All right, so now we need some numbers. Looking up at this one here, I've got 4 of them, it looks like. And carbon, carbon, I've got 1 of those. Oxygen to hydrogen, looks like I got 2 of those. And this is a lot of accounting, so I know it's tedious, but I don't know, we got to do it. For this one here, the oxygen hydrogens, I've got 2 of them. The carbon to hydrogens, I have 4. And then the carbon oxygens, I have 2. And then the carbon to carbon, I have 1. Okay, so any doubles I have, I can completely get rid of. So 4 carbon hydrogens, 4 carbon hydrogens. I don't need to worry about those. They cancel each other out. Oxygen and hydrogen. I've got 2 of them, and I've got 2 of them. So it looks like I can discount those. Is there anything else we can get rid of? I think that's it. Okay, then from here, let me show you just the resource that I'm going to use. It is right here, and I took this right out of your book. The quality here isn't super good, but it is in your book. It is table 8.4, and it shows all of these individual type bonds and the enthalpy values that goes along with them. So there's a whole series of them. You got your multiple bonds, double bonds, triple bond things down here. And so I'm referring to this table when I choose the values that I decide to put on here. So we'll go back over to, where's my screen at? There we go. Okay, so we'll come back over here and I'll find values for these. The carbon hydrogens, of course, I don't need to worry about anymore. They're gone. And then 614, these are all kilojoules, plus oxygen is going to be 146. So I have this sum total of those two. And then swinging over to here, the carbon oxygen, I have 2 of them. Actually, I'm going to bring this down because this is going to get in my way. So I write 614 plus 146 minus the carbon oxygen. There's 2 of them. So I'll say 2 times 358 from the table. And I will, because I'm going to sum all these guys up, I'll leave this as large, plus the last one on our list, which is the carbon-carbon double bond, and that is going to be 348. So 2 times 358 for the carbon oxygens, and 1, 348. And if we add all of this up, we end up with negative 304 total. And again, those are kilojoules for that total of the process. For part B, let's take a look. For B, going through and cataloging these guys, so I'll try to put it where you can see. This will be tricky. 4 carbon hydrogens. So say 4 carbon hydrogens plus 1 carbon-carbon double bond. So I'll just kind of say it and then write it. You won't actually see this. So 1 carbon to carbon double bond plus 1 carbon to hydrogen bond in the other compound, and a carbon to nitrogen triple bond. And then minus the sum total of 5 carbon to hydrogen bonds and 2 carbon to carbon bonds plus 1 carbon to nitrogen triple bond. And I believe that's the whole thing for this compound. So the sum of these two minus that. Now, as far as things that we can cancel that are found on both sides, 4 carbon-carbons, 5 carbon-carbons. So I'm going to get rid of this, and I'm just going to circle this just as a note that I have 1 left. Carbon hydrogen. So it looks like those guys might all be gone now, because here's the 4th one, and then I have this one left over here. So I guess those are completely gone now. And anything else? I think there's one more we can get rid of. Carbon, nitrogen, carbon, nitrogen. So it actually simplifies up pretty good. I got to take care of this, and I've got 2 of these. So that's interesting. It actually is a lot less than what it appeared. Looking this up in the table, I can do that now. That is 614, and that's everything. And then subtract the sum total of 2 carbon-carbons, just like it was before, 348, and the total difference is 82 kilojoules. So also exothermic. So both of these ended up being exothermic values. That's it. That's the end of the lecture.